All right, my system has 9:45, so I'm going to get started here. All right, awesome. Hello, Star Trek. I am Matt Eland, what is it now? A senior solutions specialist 2 and AI specialist at Leading Edge here in Columbus, Ohio. And this is making your code suck less without setting fire to production, hopefully. So anybody here ever encountered something called technical debt or maybe heard about it from a friend? I certainly have never inflicted it upon anybody else, but I've seen it once or twice. And I have to tell you, this talk is because I and many others can tell you that Code Cthulhu is real. Code Cthulhu is this entity that lurks in your legacy code bases, waiting to devour your sanity, happiness, productivity, and end users. Now, I know this because I have found myself in various roles having to deal with technical debt. Whether that was as an individual contributor, this is less Photoshop than you would like it to be, by the way. This is far less Photoshop than you want it to be. But I've caused technical debt, sadly. I have helped resolve technical debt. And now I help consult to manage technical debt with other consultants as well. But it's a very real thing that has a measurable impact on our businesses, on our productivity, on our users, and our ability to get things done that people need us to. And it's such a big deal that I was actually persuaded last year to spend a decent chunk of my year writing my first technical book on that, called Refactoring with C#, or C#, depending on your pronunciation preferences. And I'm going to back up here and define technical debt, but I don't like my words as much as I like other people's words. So I'm going to start with Adam Tornhill's definition from Software Design X-Rays. And Adam defines technical debt as code that's more expensive to maintain than it ought to be. I love that word expensive because technical debt costs you something, but it's vague on what it costs you. It does cost the organization money in terms of developer time. It costs the organization developer happiness. It costs end users bugs and a poor experience. And it just ultimately limits your ability to get things done or get things done well. Now, this is probably my favorite definition of technical debt, but a more catchy one would be Michael C. Feather's definition for working effectively with legacy code. He says it's code without tests. And that's nice and catchy, but I have seen plenty of code that has tests that I don't want to touch with a 10-foot pole because it just makes me want to shower afterwards. By the way, this is a very good book. I would definitely recommend reading this book. I'll close with a couple other recommendations of those as well. I define technical debt in my book, but I'm also a lazy man, so I didn't read what I wrote. So I had made up another definition, so you can take a look at what I wrote. But what I came up with for this talk was technical debt is potentially addressable risk that your current code, architecture, infrastructure, or data will negatively affect you in the future. Now, that potentially addressable bit, I think, is key because there's risk in everything we do, but technical debt is something we can proactively do something about if we choose to. Okay? So let's do a little pulse checks here to see if you have signs that Code Cthulhu is lurking in your code base. So there are various signs of technical debt. I think many people can recognize the ones that start with the gag reflex when you're looking at code or architectures or decisions. But one of the big decisions that you'll see, by the way, I have a lot of Star Wars slides in there, so bear with us. They're from the 2 trilogies of Star Wars movies, as well as Andor and Rogue One. They really should make something after Return of the Jedi. Anywho, you may have technical debt if when you try to change code, stuff breaks, right? You try to change an area, that area breaks in ways you didn't expect. Or when it's really bad, you try to change an area and a completely different area in your code, just seemingly unrelated, breaks almost at random, and you have no way of detecting it. That's a good sign that you have technical debt. Another sign that you have technical debt is that those pesky bugs take a lot more time to spot and resolve than you would expect they would, right? They tend to cling on and hide, and you have to spend a lot of time debugging and resolving and figuring out what's even wrong, let alone how to fix it. And so you spend a lot of your time fighting bugs in this epic war with bugs that are swarming all over your code base and affecting your users. Right? And so the result of this is you tend to get a lot more cautious, whether you realize it or not. And you have this fear of changing things, right? You don't want to make any sort of change to your code because you don't want to be the guy or gal who broke things, right? I don't know if you've ever been there, but nobody likes getting yelled at for doing their job and accidentally setting fire to production. Right? And the net result of this fear and the net result of this complexity and technical debt that we have is that even when we're not doing bug fix work, which we're doing a lot of, our feature work is taking a lot longer than it ought to. making a simple change takes more time than it would otherwise, whether it's because the code is a mess of spaghetti or because you have to do a lot of work to make sure you're not breaking everything. The end result of this is that you're trying to release code, you're trying to release new features, and things inevitably get pushed to the next sprint or next release or whenever it is, right? And so when you see things habitually get moved out of different releases, that's often a sign that you have a lot of technical debt going wrong, or you just can't adequately control your environments or resolve things. Okay, so the net result of this is typically a displeased senior management, right? By the way, I've now worked at 2 organizations that have a Matt Sith emoji. It's less Photoshop than you'd want it to be. But yeah, management gets displeased. They want to be able to predict when things are going to change, when things are going to go out there, and that they're going to go out there without bugs. So when this goes on for long enough, people lose hope, whether it's developers losing hope, or it's management losing hope, or your product owners, or your users losing hope that your application is going to get better. And when you start losing hope as a developer, you stop trying to change things. You stop trying to make things as good as they ought to be, right? And so you become kind of this maybe lackluster, laid-back, cautious developer, and you're not the best version of yourself, and your organization's not getting the best version of you either because you're being so cautious and conservative. Okay? And if this goes long enough, you'll eventually say, well, wait a minute, I hate this organization's technical debt. I can't resolve it. I'm going to go somewhere else that has no technical debt because everybody else has no technical debt at all, right? And so you leave for greener pastures. And by the way, why is it always farming? When people get out of software engineering, a lot of the times they go to farming. I don't know why. But yeah, but when you lose people, it hurts you in unexpected ways. Right? You have lost that knowledge, you lost the talent, you lost the throughput of the person, but you also lost why they made their decisions. You know, they can document this is a for loop, this is a ternary statement, but if you don't know why they made their code decisions or what other options they considered, well, now you're going in there kind of blind and maybe making the same mistakes that they made. That this path doesn't lead well, but they didn't document it. You've lost their knowledge, right? And it can be hard to bring on new developers, and if you do, you know, there's some challenges you might face there. But the net result of this is that our applications become degraded, right? They are no longer functioning the way that we wish they were, and we're no longer as proud to be developing these applications. And as a result, our teams are degraded and demoralized. And you really lose hope that things could be better, and that causes your technical debt just continue to pile up and skyrocket until the application is almost a total loss. So my key takeaway for you all today is it does not have to be this way. Okay? There are ways of paying down technical debt. There are ways of doing it safely. There are ways of doing it iteratively. And there are ways of doing it maturely. But we need to kind of understand where it comes from first. Now, some technical debt comes because I haven't had enough Diet Dr. Pepper in the morning, and I'm just going YOLO on my commits. But I think the majority of our technical debt comes because of natural entropy. We have this entropy factor that affects us in software engineering, where any line of code that you write has a shelf life on it. I might create a new .NET 8 or even 9 preview project today. That has a shelf life. There's going to be a certain point in 2 years where that LTS version is no longer in support and I need to upgrade. There's going to be different changes that happen in the software engineering industry, such as, well, we really want to use JSON right now, but next year we're going to all move to YAML or who knows what, right? There's natural trends in the industry that happen. And then the context in which we use software changes. So yeah, I don't know if anybody here has ever experienced this, but I've heard of some people that develop a feature that's supposed to do something, and then your organization changes your priorities, or you change your mind on what the feature should do. Well, you still wrote your code that way, and it's designed to serve that, but now you have to bend it to serve this other thing as well. Or, oh, let's just bolt on this other feature that this was never intended to do. This is how we get technical debt. It's a natural part of the software development process. We are never going to be free of technical debt on any project that we write. But our job as developers is to manage that debt through the process of refactoring. Now, refactoring's definition is the process of changing the form of something without changing its behavior. So taking something from a less maintainable state to a more maintainable state, less testable to more, that kind of thing. And I was going to make a nice little refactoring demo for you all, but I'm a lazy man. And so I plagiarized myself. So here is an example from chapter 2 of my book. And this is an example involving an airline company. And this method here is going to price out how much a trip will cost you based on the number of bags that you're checking, the number of bags that you're carrying on board, and whether or not you're flying at the holidays. It's about 30 lines of code long. I've seen worse things. I've written worse things myself. But it's not the most maintainable thing. It's not the easiest thing to understand and internalize, and that's kind of the point of this brief little exercise here, is that it takes you a little bit to understand it, and you might understand it incorrectly just at a quick glance. And if you understand it incorrectly, you might break it when you're making a change. So let's look at the process of iteratively refactoring it. We'll start with this little chunk here. So this is our carry-on baggage price calculation. So Matt's overpriced airline likes to charge 30 bucks per carry-on. Let's say that I get a little greedy in the future and I decide I want to charge $42 per bag. Well, now I have to change two lines here, 18 and 19. And if I only change one of those two lines, I have a bug. I don't like making opportunities for future me to make bugs, or worse, my coworkers, because I really don't trust them. Yeah, I'm looking at you, Brian. So what you can do here is you can extract a local variable. You introduce a local variable. You say, hey, we're going to add another line of code, but that line of code is going to carry my calculation. If I need to change it in the future, well, I'm only changing one line of code to get more profit for my users. Because that's what we do. The prices never go down, do they? The nice thing about this, aside from charging our users more money, but the nice thing about this is these kinds of refactorings are supported by our tooling. Right? So whatever development environment you use, likelihood is it supports some sort of refactoring tools. So Visual Studio Code is a screenshot here, and it supports things like extracting methods, introducing variables. You know, the JetBrains suite of IDEs all have these things baked in, as does Visual Studio and most other professional development environments. I like these because these environments are going to reduce your odds of making a mistake changing things manually, right? Sometimes these have issues. Most of the time, they're very reliable. 15 years ago, they used to have a little bit more issues, but I was actually bitten by a bug that one of these things did to me this week, working on a one-night Ultimate Werewolf simulator. So ask me about that later at lunch or something. But the point is, these are very reliable, generally speaking, and they're going to make fewer mistakes than you otherwise would. We'll talk more about safety later on. So if extracting one variable made things a little bit more maintainable, well, certainly let's extract another one and see if it helps. So here is our logic to charge based on the number of bags that you're checking. And here we're charging a special rate for the first bag, and then past that, we're charging a separate rate for additional bags, because airlines like to do that. So we'll start by extracting a variable again. And we'll see here, my code is now significantly taller. I've added, 3 lines of code here with this. But I'm now calculating a first bag fee. But bear with me for a moment here, because we can also change this to have a fee for the second bag. And when we do that, well, now our if-else is just figuring out what our fee is in this scenario where you have the same amount of bags or fewer as the number of people who are traveling, or otherwise. And now we're able to move our logic down to the bottom to actually log it out to the console, or to increment our total, things like that, right? And when you look at this, you'll think, okay, well, this is about 20 lines of code that's all doing about the same type of thing. This is really kind of its own little method. So you can use the extract method refactoring and just saying, like, hey, in that base method that we're working with, we're going to call a new method here that I created called calculate check bag fee, and that's going to have all that logic we just showed. So we're removing complexity from that one method, and we're adding it into its own method. And this method now is unit testable potentially. It's easier to understand, easier to maintain. It's harder to mess up. So the Brian factor is lower, we'll say. Sorry, Brian, I like you. But doing this actually points out another problem for me. It's like, oh, hey, there's an opportunity here. We have this if bags is greater than 0. Well, I don't like this indented code when I'm really not doing anything else, so let's invert the if condition, and now I'm just doing an early return, and my code below that is easier to read and understand. And so if extracting one method worked well, let's extract a couple more. And so we have methods now for the holiday fees and the check bag fees, or sorry, the carry-on bag fees. And what this lets us do is our core method is now significantly easier to understand. We're now well within the 20 lines long limit that I like to set. I like my methods to be 20 lines long or less, my classes to be 200 lines long or less. These are just preferences that I've found over my career for .NET code specifically. And doing this shows me, well, wait a minute, I'm really kind of just calculating a subtotal, and I'm sending that subtotal into the calculate holiday fee, but it's not that clear. So we can do a little bit of more refactoring, we can combine these two things together, and we can add a comment. Remember, comments are documentation, they're important too, they can be part of refactoring too, and that will tell people what we're doing here and why we're doing it. So when Brian comes along, he knows, oh, I can't just total everything up afterwards, I need to send it into this method here. And so, is this better than what we started with? Maybe, we don't know. What we started with worked, or at least worked most of the time. We only know if the new version works by testing it. We can do that manually, we can do that via unit tests. Unit tests are your best friends forever. And in this case, the past developer here, which would be me, had some unit tests around it. So I can just say, hey, .NET test, and it runs my tests, and it says, hey, everything is good and golden and green. Maybe I'm adding new tests as part of adding this on. But in this case, these look to be equivalent, but more maintainable. So that is refactoring. I'm changing the form without changing its functionality. Okay? But refactoring at the code level is something easy to understand, and I think most of us deal with it on a day-to-day basis as we can. We'll talk a little bit more about that later on. The more impactful refactoring is, really are at the architectural level, where you're starting to say, hey, I've got all these classes, and I don't like the way they interact. They were built in a certain way. We have a lot of duplication going on. There's a lot of complexity we don't need. Boy, I'd like to spend some time refactoring this. I'd like to spend some time cleaning up the architecture. Maybe I'm going to introduce inheritance or composition or whatever I need to address my issues, right? So these larger refactoring at the class or component level, you're now starting to modify multiple files at the same time. These tend to take a little bit more coordination with your developer teams. You often will need a work item for them just to work on at that level. But they can be really important for ironing out your systems, especially when your systems are serving functions that they weren't originally intended to. One thing that we don't usually remember to do is to refactor the database. Typically with a database, whether it's relational or non-relational, you start with a schema or intended use of it, and it just grows over time as you add more data that you're storing. And you don't ever really iron out the kinks in your data. You might sometimes prune your tables if you have things too long, or you might add some indexes if you're having poor performance. But it's rare to spend dedicated time just kind of straightening out your database, making it make sense. Sometimes you actually need to denormalize your data, believe it or not, to get better results, better performance. And those are kinds of things that need dedicated thought associated with them. And I don't think that we talk enough about refactoring databases. So when you are trying to put on the superhero cape and saying, I'm going to go refactor my code, I'm going to make everything better, there are two main obstacles that come in your way. The first obstacle is scheduling concerns, and we'll talk about that in a bit. The second one is probably the easier one to address, and that is quality concerns. So with quality concerns, you're basically saying, am I going to break everything if I go in and try to refactor? And if so, what can I do to prevent that? Well, the obvious answer would be unit tests, but you don't always have unit tests to start with. So sometimes you'll join a new team or new organization or new client, and there is not a testing culture in place, and you don't have that safety net in place. So what do you do if you don't have unit tests or you don't have reliable unit tests? Well, the first thing you do is you buckle up because you're going to have to do some manual testing for a while, right? Every developer, even if you have exquisite unit tests, you should be testing your software manually because there's certain things that you're going to catch with your human brain that software isn't. You know, AI is wonderful, and we're going to get to the point where it can help us find more things, but we're not there yet. Right? So you're going to have to do some maneuvers and fly things on your own. And when you're making your changes to an area, if you're an experienced developer, you usually have an intuition about the ways something could break. Sometimes it's going to be, oh, if I mess this up, the compiler is going to catch it. If I forget to implement this method, well, the compiler won't let things compile. So I'm going to lean on the compiler. It's going to help me out a little bit. Other times, you know, well, hey, if I launch this sucker, I'm going to get an error, right? Like if I forgot to register my my dependency injection dependency, well, I'm going to get an error screen like this. Anybody seen this screen before? Anybody seen this screen in production? Oh, please put your hands down. Don't have developer exceptions on in production. Those are the kinds of things that are kind of easy to spot with a smoke test. But there's these more subtle things. If I mess up the price calculation for my airline, it might not error, but it's going to be wrong. And a user is going to have to tell me about it in a few months, and we'll have to validate that they're actually right, and we'll have to resolve it there, right? If you get bad data into your system, that can take eons to just expunge that and correct that, right? So you have to think about the level of risk that you have with the things that you're doing and take an appropriate strategy based on the risk that your application works or won't work. If you have if you have no tests, you probably have a lot of bugs, and that's good news. Why is that good news? Because you have a lot of bugs to pick from when you're going to start your new practice of test-driven development. So you're going to pick your easiest bug to fix, and you're going to go in there and you're going to write a test that goes red, it fails. Right? And so you're going to go in and say, okay, I'm going to write a test that says when the user clicks on the login screen, it shouldn't delete his account. All right, I'll write that test. It's going to fail right now because it currently deletes his account when he tries to log in. It's a bad system. And then I'm going to fix the issue, and my test will turn green. And then I'm going to refactor my test. I'm going to refactor the code that I added, maybe some areas immediately around it. I'm going to move on to the next bug or the next test I need to add to this. And once you get this practice under your belt a little bit, it becomes easier and easier and easier to do this for future projects. Now, there are some pieces of code that are harder to test than others. For example, if you're testing the user interface, that can be harder to write unit tests around because you have a lot of UI dependencies, you got a lot of delays for things loading and things like that. There are frameworks out there like Playwright that are really helpful for UI test automation. That's not an area I excel in, but I know some people who are very good at that kind of thing. Other types of things would involve dependencies. So if I'm testing my code, I don't want my code to actually send you an email every time I'm running my unit tests. So or talk to the database or talk to an external API or whatever it might be. So in these kinds of things, you would mock your external dependencies. So if I don't want it to actually email Bob over there every time I log in, well, I'm going to go in there and I'm going to mock the email client and say, hey, when you get a request to send an email, just return true. Right? So that way I'm just testing my logic. I'm not annoying Bob again. Sorry, Bob. The problem with this, and I love mock and things like mock, but the more you lean on things like this, the more complexity you get in your tests. The harder your tests are to read and understand and maintain. And once that happens, now you need to basically clean up your lab, right? You need to start working on refactoring your test cases so that setting up new test cases is easy and the existing ones are easier to understand and maintain. Because there's a price to this complexity we have to add sometimes, and you want to reduce that complexity so that new people joining your team are going to be comfortable writing tests. And in general, if I have to scroll while reading a unit test, I know I'm doing something bad. I need to fix some of mine at work right now, actually, now that I mentioned that. But this is important for ongoing health and maintainability of your systems. So there is a risk that you do all of these things and you deploy to prod and things still blow up. I love robot chicken. It's just wonderful. So there's still this risk that you have, right? So what happens when things blow up? Well, you think about how did things escape my net of tests? How did things escape my manual testing? And what can I do to make it not do that in the future? Sometimes it's, oh, we need to test for this kind of thing. Oh, we need to do this kind of a smoke test. Other times it's, I need bigger tests. For example, the difference between a unit and an integration test is I'm testing a small unit of code versus I'm testing how things integrate with each other. So here in this GIF or GIF, depending on your religion, we have a working lock and we have a working door. And they integrate, but boy, do they not really work together. Call this modern application security right here. This is maybe more my favorite. It's two automated doors, right, or gates, and they are motion sensitive and they are sensing motion, and so you have a perpetual motion machine that's working fine. It does deter people from leaving your store, so maybe you sell more things as a result of this. But integration tests can help you find more bugs, but they tend to be slower. They tend to take longer to write. They tend to be I don't know, harder to maintain. So there is a price to them, so you have fewer of them than you have integration tests. Than unit tests. But they can really help you out with things that your unit tests won't find. So let's get to maybe the trickier aspect of things, the scheduling concerns, right? Raise your hand if you are on agile with sprints and the like, okay? Many hands, that's fairly normal. Anybody experience what I would like to call the end of the sprint crunch, where you're trying to get everything done, and yeah, okay. So I send somebody a pull request, and they said, Matt, why are you using this over here? It really should do this. I'm like, okay, that's a good point. That's gonna take a day and a half to do. The sprint ends tomorrow. Let's just fix this next week, next sprint, right? Like we can do that, right? And once that starts happening, you have this basically established practice in your team where 25% of the time your standards are lower. And that's just basically an automated factory for getting technical debt into your code because your standards are lower at the end of the sprint. Now, there's a reason we do this, and that's because people are relying on us to get things done, and it's important that things ship. The way we can address this is by shipping more frequently. If we have more frequent releases, then the cost of missing a release isn't as bad. If I release every month, well, it's pretty bad if I didn't make the window, right? If I release every 2 weeks, it's less bad. If I release every week, okay, that's still an inconvenience, but it's usually doable. If I release every day or multiple times a day, then okay, I missed the bus, there's gonna be another one in 5 minutes. And we can do things right. And the consequences of unexpected delays are significantly lower. Now, to do this, you need a lot more automation and maturity in the DevOps spaces and the like, but this can really help you get to better ground. Another technique that I think really helps us manage our debt over time is the Boy Scout principle. I'm not sure I love the term of that, but it is the established term of that, and it comes from the Boy Scouts when they camp. They say, hey, we're going to leave the campsite as good or better as when we found it. When you're modifying code, you're going to leave that code as good or better as where you found it. Right? This has the additive effect of the places that are modified the most frequently tend to get better over time. That can help you pay down the lesser forms of technical debt in the places that are frequently modified. Other things, such as introducing new classes and changing your inheritance hierarchy, working on how you do dependency injection, or changing API definitions, those are larger things, and they will typically need their own work items. So you have a dedicated work item for cleaning up this piece of technical debt to iron out the system, make it more reliable, better, whatever you need it to be, but you have this go into a sprint. And that's great because it gets tested, people know about it, it gets measured, and it's assigned to somebody, and everybody knows about it. It's less great because your product owner is now saying, oh, if we're cleaning this up, what don't I get this sprint? If we're spending time on this, well, what about my feature that my users are yelling at me for? And so this creates this natural tension because people want their features to be delivered, right? And I think there's two ways of addressing this. The first one of saying, how much of our time do we spend on bugs right now? Would we like that to be less? Okay, we'd like that to be less. Well, let's put in more technical debt cleanup items with the theory that this will reduce the amount of bugs that come in that we have to deal with. So let's spend more of our bug fix time on tech debt resolution. It doesn't always work out that way, but it can. Now, the second way of looking at this is saying, okay, what I'm hearing in your objection to including this tech debt item is that it's not delivering value to the business. Let's talk about the value that it delivers to the business, right? When we are paying down technical debt, we're addressing potential risks that our applications are going to incur in the future, that things will break, that we won't be able to meet our needs as our users grow, things like that. So having those conversations about scalability and benefits with users, I think is really helpful. I'm going to hide a little bit behind my lectern here as I say this, but not all technical debt is bad. Okay, I have worked at small startups that have had aggressive deadlines around trade shows where we needed to have things demoable to close major deals or do other things, right? And so we would say, hey, we're going to ship whatever we can to CES or whatever other conference we're going to, and we're going to do whatever smoke and mirrors we can to get a demo up and running so we can stay alive as a business. I've been there. It's a lot of late nights with pizza, I can tell you that. But it is fun. But that's a place where you're strategically taking on technical debt, just like you might strategically take on debt with buying a car or something like that, right? But that debt is going to cost you. You're going to be paying down the principal, and you're going to be paying down the interest over time in the terms of new bugs that come up or the ways it inconveniences you working on features in the future. Right? So you ultimately generally will pay more for resolving your technical debt than you would gain from it, but sometimes you need those short-term gains. So this is a good example of taking on strategic technical debt. Bad example is I haven't had enough Diet Dr. Pepper and I'm going to YOLO it, right? That's a bad business decision. But technical debt is not always bad. Sometimes it can be helpful for your organization. So let's shift gears with a lovely little GIF. Yoda is... That is not patience. I don't know what that is. But let's talk about how we do things and some ways of making things better. I like to periodically ask myself, as a team, as a software organization, as a code base, are we getting better or are we getting worse? Is the garbage going up or is it going down, right? Are the walls closing in or are things getting better? And that's a good question to ask periodically. And if the answer is no, For me, it's almost always a result of code reviews. If you're not having code reviews at all, that's a problem. If your code reviews aren't catching issues, that's a problem. If those issues aren't getting resolved, that's a problem, right? Every code review should be giving the developer some feedback on something, whether it's just like, oh, I liked what you're doing here, or dude, don't use var, whatever it might be, right? But every code review should add value to the organization, and it's not something that you phone in. It's a part of your job as a developer, as an engineering leader, as a general engineer, and it makes everybody better. Code reviews can often be about style, and that can really derail a conversation when you're trying to implement a new major feature. You want people to understand, like, hey, this is what we're concerned about. Okay, I didn't indent my curly boys the way you wanted me to. Okay, fine, but what about this thing? What about the thing we're trying to address? I found that tools like Prettier, that will automatically format your code in a consistent way, even if I don't fully agree with the way it consistently formats things, can help your conversation focus on what actually matters instead of on the style of things. Having a style guide can also help your organization too. Your code review process should be augmented with tools that integrate into your pull request process. So if I'm reviewing code, I'm assuming that code builds. I'm assuming that code has passing tests. I'm assuming that my Terraform checks are working fine, and maybe even that it passes certain quality gates from a tool like SonarQube or Sonar Cloud, right? And once those things are met, well, now it can get reviewed, and we can focus on what the code is actually doing, and if it's secure, and if it's scalable, and if it meets the client's needs, right? Instead of focusing on like the little minutia of things. So these are things that will really help us out. All right, let's shift gears yet again and talk about teams, right? I do maintain that Lucas was right, that Jar Jar was the key to everything. Darth Jar Jar is real. So some team concerns. If I join a team and I am the only person testing, I can tend to feel a little lonely. This is an actual picture of me feeling a little lonely. I had my glasses off that day. If nobody else is testing, and you're talking in stand-up every day about you're writing tests, that can lead to some interesting conversations. You need to show people that you are still staying afloat, you're still keeping up with everybody else, that these tests are delivering value, and that they're delivering value over time. So next sprint, when Brian comes in and he tries to work on my feature, and he says, Matt, I have this wonderful feature here, it's working, but your tests are broken. I was like, well, were they broken before your code? Well, no, but Matt, fix your tests. Your tests are slowing me down. Well, no, they're helping you from hurting our users. And the more you can help people understand the value of tests, the better things are. That's usually not the issue, though, in this day and age. It sometimes is, but it usually is more people have a fear of, how do I test this code? How can we test this untestable mess? Right? And if you can show them, here's a pattern of how we test this. Here's a pattern of writing an integration test. Here's a pattern of writing a unit test. Well, now you're on their side. You're their ally. And now you get the rule of two going on, and pretty soon you have a Sith army of testers. So that's pretty cool. So if you have a new person joining your team and you have a mess of legacy code, one of two things happens. The first thing that happens is the person joins your team and they look at the code base and they're like, seriously, you live like this, bro? Like this is fine? This is fine? The other thing that happens is the person says, oh, this is how we do things here? Cool, got it. I'm going to copy and paste this pattern everywhere. I'm going to make as much features as I can. I'm going to make it all look like this. I'll check in with you next month, boss. See you later. Both of those are terrifying, right? Both of those are terrifying because our code is never the way that we want it to be. It just isn't. We always have legacy code. We always have technical debt. We always have things we want to improve. That's just the nature of software engineering. But you can help people out when they join your team by saying, hey, here be dragons. Here's my code. Here's the stuff that we're not proud of. We really want to fix it. We haven't gotten to do that yet. Here's our latest and greatest stuff. This is really what we're trying to write. These are the patterns we're trying to espouse. Don't you dare copy from over here. I will slap your hand in the code review, right? You help people understand where you are, how you got here, and where you're going. They're going to judge you less, and they're going to hopefully do less copy-paste driven development, or if they do, they're going to copy-paste from the answers on Stack Overflow instead of from the questions, right? A lot of copy-paste driven development, you try to nudge people towards extracting methods versus trying to copy things over. That can be a journey, especially with newer developers. But if they're copying the bad code, that's even worse, right? And it's not done yet because in this new day and age, we now have not just copy-paste driven development, but LLM-driven development or ChatGPT-driven development or Copilot-driven development. And the stance you need to have is, look, okay, here are organizational policies around using this and keeping our data private. If you do choose to use this in accordance with our policies, you own this code now. This is your code. You have to be able to explain it. You have to be able to maintain it. You have to be able to test it. So let's make sure we understand this and this is good to go. Because when you're sending it to me in code review, I'm assuming that you fully understand this. And so this is where things like communicating standards inside of code review can be really helpful. Organizational standards on how we should work, how we should use tooling, things like that can be really helpful, especially when you have new people joining your team. So let's talk about that really critical part where a lot of technical debt resolution fails, is getting buy-in for those larger work items. If you have something you really care about, you really need it to be improved, you have to have that critical conversation with somebody saying, like, dude, we got to get the dead raccoons out of the walls here. Like, what are we doing here with all this tech debt in our code? And that conversation is going to be with one or two people. It's going to be with somebody technical, or it's going to be maybe with a product owner or a scrum master, somebody like that. When you're talking to an engineering manager, you're saying, hey, here's my technical concern. Here's how it's hurting me right now. Here's my potential plan for remedying it. Here's other things I considered. These are the tools I'm going to use. Here's who I think that we should be involving in this project and how we should test it. Okay? This is how long I think it's going to take. And your product owner is going to be thinking about other things. They're going to be thinking about what don't I get during that time? Are you just going to come back to me next month and ask for more time on other things? Are your estimates accurate? Are you going to break everything? Are you even the right person to be doing with this? And is this a real issue, or is it just you don't like the curly boy indentation patterns here, right? So when you are doing these presentations, you need to be specific. You need to say, hey, this is what's hurting us. This particular area right over here, we're having a lot of issues in this area. What I want to do is I want to go in, introduce this new thing, phase out the old one. Here's how I'm going to test it. Here's how this whole project is going to work. The way you communicate that's going to be different based on if you're talking to an engineering manager or product owner, but you're treating them with respect and transparency. Okay? You want to bring data, not the Android from next generation, sadly, but you want to bring data supporting your thing, such as, hey, here are the bugs that hurt us in this area last quarter. Here are the metrics for performance in this area. Here's how this has impacted these particular JIRA tickets or whatever it might be. Right? So you help people understand the specifics and where you're coming from. That says, oh, this is not just your opinion. This is what our data is telling us. The other thing that can really be helpful is you want to be personal. So you can say, hey, this really, really, really hurt Mike last sprint. Right? Mike was trying to add this feature that you really cared about, and he found out that Brian just made a mess of this place over here, a month ago. So we got to clean this up, right? Or we can say, like, hey, this really hurt this major customer of ours because they can't add the things that they need to add because the system doesn't support it. We need to make things better for these particular people. Your goal is to create this partnership between you and the business side of things, where you're both trying to get the best product as possible, whether that's by adding new features, by fixing bugs, or by getting things ready for what's next. And you're naturally going to get pushback of, well, I really need to commit. We have this urgent organizational need. Well, you might have that urgent organizational need, and you might need to wait on your technical debt resolution. But when I'm talking to a product owner about caching, their eyes start to glaze over. But when I start to say, like, wait a minute, we can't support 10 times the users that we have right now, and our business goals, as stated, say that we want to grow 20 times. We need to fix this to achieve our goals. There's a risk in our current stuff that we're not going to be able to support where the organization wants to go. It's like, oh, okay. Oh, and this is hurting us where? Oh, and you actually start to track this over time. You create a risk register, and you say, whether it's in Excel or in JIRA work items or in a Confluence page, whatever it might be, you're tracking your major risks that might affect your organization and how they affect you each month or each quarter. And you will sit down and you'll review it with them over time. You'll say, hey, this is how this hurt us last quarter. I think this is an issue still. We did some work to resolve it, but it's not completely better yet. We still have this to do. And you're kind of working with them to create a partnership on, we want to pay this down, but we want to do it in a responsible way on the business's timeline, mixing in our urgent needs and organizational goals as well. So again, these folks are not your opposition. They are your partners. And your goal is to have this partnership with them to build the best products you can and deliver it out there. So when we're paying down technical debt, where do we start? There's a lot of different ways you can do this. I am a big fan of starting where it hurts you the most. So you might look at the major areas of your application that have been hurt the most by bugs. This is a visualization here of the frequency of bug fix commits to various files in a system, something I'm working on for my master's degree. But you can say hey, the areas that we're getting a lot of bugs in, that's where we probably should pay things down the most. That's the most important thing, right? The other thing is maybe a little bit less data-driven. Who here has had a nightmare about code? I have, right? The things that eat at the back of your mind and saying I am afraid of this code. I'm afraid of going into this file, of touching it. It's devouring my sanity. That's valuable, right? Especially if other people on your team are also afraid of that same place, right? Then that's not just you. You may not have the data to support it, but there's probably something to that, especially if you're an experienced engineer and you've seen a lot of stuff, right? So don't ignore your intuition and your experience and the things that you just hate to touch. Things that change most frequently tend to be the places that are going to break if you make mistakes or if you have legacy code in them. So prioritize those areas, not even just things that have had bugs before, but things that you think, well, we're probably about due for a bug over here, aren't we? And then your product owners know where things are going to go, right? So if you're going to be expanding a wing of your house next month, well, let's make sure the foundation is solid, right? And then finally, our tooling can really help us out. So if you're using a language that has linting support or code analysis warnings, something like that, well, you're going to have warning density. You're going to say, hey, we have a lot of warnings in these areas of various severities. Let's take a look at the areas with the most warnings. Code analysis tools like SonarQube, SonarCloud, Independ, other things like that can really help you find these hotspots. And I like to really actually look at some metrics from code in particular. So code that has a high duplication percentage, that's something that I like to prioritize. Methods that are very long, I like to prioritize those. Classes that are very long, those tend to be hotspots for technical debt as well. Not everyone is, but those are ones I will often look at. The other scary term that you'll hear sometimes is cyclomatic complexity, and that's a scary term that just means the number of unique paths through a method. Right? Methods that have a high cyclomatic complexity are harder to understand, they're harder to test, because you got so many permutations of things that might happen. So if a method has a high cyclomatic complexity, you may need to pay down to debt there, or it may just have a really long switch statement. It could be one of the two, right? I don't usually care about tall switch statements, but if I have a whole lot of if-elses, well, now we're going to take a look at this and see, hey, how can we make this better? So let's take a look at the colossus in the room, and that is, okay, this code is awful, we just need to burn it to the ground and rewrite it, right? By the way, the first version of this talk I gave had a whole lot of fire references in it. I'm not sure what I was on, but yeah, there's a lot of fire in that first one. So the Star Wars theme is welcome here. Rewrites are great because you are done with this. We're going to go away from you. I don't have to worry about you anymore. Cthulhu is going to just get sailed off into the river and burnt, and that's fine. Except most rewrites are going to fail for a variety of reasons. Your code that exists for a reason, and you've been working on it for a while. You have a bunch of features. You've spent years building these features. Well, now your rewrite needs to have these features too. While you're spending your time building your rewrite, well, you can't launch it until you have feature parity, right? So you probably have your best developers on that. Your best developers are no longer working on the legacy product. If bug fixes come in, if new features need to be added, well, now you got to think about, are they going into both places or just one? And then when is this going to be done? And can we actually estimate that? Usually we can't. And all these things. And usually organizations have priorities that come up, and these rewrite projects tend to be long-running and then abandoned and filter out. And they tend to just sort of lead this decaying life where they just were like, oh, that would have been great if we could have done that, but we just can't. Or you hurry and get it done, and you incur a whole lot of technical debt in the process, defeating the point of the rewrite, right? So there is a better way, and to announce it, I have my favorite slide in the whole presentation here. The solution is to chop things off, right? So here is Luke going on a weight loss program for his hand. But the solution is to chop your application into pieces, and specifically vertical slices. You can take that lightsaber, you're going to chop pieces off your application. So for example, my flight management system, I'm going to take a slice out of that system. I'm going to say, hey, we're going to take this book flight functionality, and we're going to make this into its own separate area. And what you do is you just chop that off from the old app, and you put it in your new app, right? And now your old app is skinnier, which is great because you have your less of your code. You got new code over here that's proven this works. And the way you can work on this is actually by introducing a proxy layer. So you can use something like an Azure API gateway to direct traffic to the appropriate endpoint. Or in .NET, we have yet another reverse proxy, or YARP. These are all things you can say, hey, when a request comes in, if it's for this area, I'm going to route you to the new system. Otherwise, I'm going to route you to the old system. Okay? And over time, you start chopping off more and more and more of that application with your lightsaber, and your new system gets bigger, your other system gets smaller, right? And everything is still delivering value to your users. You're releasing regularly. All that good stuff that we've learned is healthy and good in the software project. Now, I think it was Martin Fowler called this strangler fig application pattern, and I love that because there's these banyan trees, and these strangler figs will just kind of creep up, and they'll wrap themselves over the branches of the tree, and they'll strangle that tree, and the tree dies, which is tragic, I suppose. But the resulting thing is still a tree. We have a tree that's just this mess of vines, and that's sort of what we're doing. Is we're getting rid of the old thing, and we have a new thing in its place. Now, the natural question that many people start thinking about, especially in the last decade or so, is, well, if we're going to be chopping these things off into new pieces, well, why don't we chop them all off into their own individual pieces? And now we have microservices, right? Microservices, I think, are a solution to a team problem. They advertise the ability to scale things independently of each other, and they give teams autonomy to maintain their own microservices. But now you have a whole lot more dependencies between your systems. There's a whole lot more places things can fail. Sometimes you need microservices, sometimes you don't. One thing they really do let you do a good job of, though, is having a small piece of code that teams can own. And there's a lot of benefit there. But I think there's a healthier place we can be. Steve Smith calls this the Goldilocks zone, but this is the modular monolith, where we have a monolithic application that has all these different modules, and your teams might focus on an individual module, they'll maintain it, they'll make it better, and it's all supported by cross-cutting concerns and a messaging layer. If you're interested in this, I actually don't know a ton about this, and I'm really excited to see it. At 11 o'clock, so right after this, Steve is presenting it in the Force Awakens room. I'm not really sure what Star Wars movie that refers to, but that should be a good talk. Steve also has some great courses on that as well. I'd check those out as well. So my lessons for you here on refactoring and making change are that we want to refactor it big and small. As you're changing code, you want to make sure that you are cleaning up your campsite as you're going. If you have bigger items, you need to have a refactoring work item in a sprint. And then you're going to start getting out your lightsaber and chopping off vertical slices when it's time to move on, right? Because rewrites will fail. Now, when we ship our software, we got to watch out because sometimes your deployments don't always go as planned. I love this, Jeff. This is great. Sometimes you'll release something and you'll blow up prod, and it's good to avoid that if we can. Some ways of mitigating against that: first of all, we can have feature flags, so we can deploy our code without releasing a feature, and then turn it on for a beta subset of users, or after a certain date, or for a certain percentage of users. And that lets us make sure our code is stable before it gets inflicted upon everybody. Other things we can do are blue-green deployments, where you have a blue environment and a green environment. It doesn't really matter which is which, but most everybody is on this environment, and you release your new version into the other environment, and you start slowly draining users from one to the other over time. And if everything is going great, you keep doing that until everybody's gone onto the new environment, and you turn off the old one until it's time for the next one. But if it goes wrong, we're going to go back, and we're going to drain everybody back onto the other one. The other thing, and this is getting very nerdy here, but there's a library that GitHub, this is actually GitHub, not like a user on GitHub, but GitHub has introduced, called Scientist. And this lets you actually take your legacy code and your new code and put them in parallel in production. And Scientist says, hey, when we get a request, I'm going to send the code to the old system and the new system. And the user is going to get a result from the old system, but we're going to compare the old and new results together. And if they don't match, we're going to log it somewhere in a table, and we can go in and fix it. So think about Matt's baggage calculator, right? If I release my new version and it's broken, well, that's no longer impacting a user. I'm just logging it in a table somewhere, and I can fix it, release it again, and things go on. So now is the point where we wrap up with our very good Palpatine thing. I'm too good at that. That's not good. My key takeaways for you all here are, first of all, you need a safety net. What you have is probably not sufficient right now. Look at what things are breaking when things change, and see what you can do to add tests around those things, new processes around things, new tooling, things like that. right? But build a QA safety net, a QA culture. Everybody owns your quality. Then figure out what's hurting you and how to address that. Not all technical debt is equal. Not all technical debt even needs to be paid down if it's in an area that's not actively hurting you. You just don't look at that file. That sometimes works, not usually. Refactor, big and small. There's different scales of refactoring, from refactoring to the code you touch, to refactoring the code that changes, to refactoring work items and vertical slices. The business is not your enemy, and features are not a bad thing. Delaying paying down technical debt is not also a bad thing. There's a right time to pay this stuff down. If it keeps getting pushed off to the future, well, you may not understand the risk of the organization has with that technical debt, and you should work to help people understand how it's materializing itself over time, because it likely is materializing itself, and help people understand, here's what we got to prioritize, here's what we have to work into our sprints, because this is killing us and our users. My biggest takeaway for you all is that there is hope. I want you all to have a new hope, so you can strike back and pay down that technical debt and just be happy about code, be productive, and have a better experience for you and your team. If you're interested in this topic, I've learned a lot from Michael C. Feather's book, Working Effectively with Legacy Code. He talks a lot about software seams and how we can test at those seams. Really good book. Adam Tornhill has 2 books, Software Design X-Rays, and then Your Code as a Crime Scene. I keep wanting to say your code is a crime scene, because sometimes it is. I have this available to give away as the first edition. He just released a second edition. I want to read it. So I have this available to get away, so come over here and chat with me. I also have a copy of Refactoring with C#, for those who are interested in .NET and interested in that kind of thing. I hope you enjoy your conference. I hope this was helpful for you. We're about at time, so come chat with me afterwards. I'd love to talk with you. Talk with me on Discord as well. But enjoy your Star Trek. It's been great to be here for 15 years, and I hope you enjoy the rest of your day.